The first one. Don't all y'all jump at once.
Could I?
Sure.
So basically what I did, in the middle of 0.2 and 0.4 is 0.3. And
Okay.
that lines up with 0.1.
Okay.
So it would be, nope, I lost my train of thought. Never mind.
Okay. All right. So remember, guys, the constant rate of proportionality is K equals Y divided by X. So I know it was hard on the paper to see where those lines crossed, but if you look closely, the line crosses right here at 0.7 and 0.3. So Y is the 0.3 and X is the 0.7 or 7/10. So we know that we can multiply each one by 10, right? And then that would give me 30 over 70, which is 3/7.
3 over 7.
Yep. Or if you did the decimal equivalent, you could do 3 divided by 7, and you would get this, 0.428. So you could say it's approximately 0.43. If you even wanted to do 0.429, you could have done that as well. So any of those would have been good. Okay? Then number 2 is a little bit easier, right? So what should we have done on number 2?
Divide 3 by 3.21.
Okay, and then what did you get when you did it that way? You did this, right? That's what you're telling me. Divide.
No, I did it backwards. 3.21 divided by 3.
Yeah. And then what should we get?
1.07.
Yep, so $1.07.
Yes.
Yep. So that's what you should have gotten, was $1.07. Okay? All right. So that's good for those two. If you will, if you were doing it in a book or if you were doing it in Seesaw, we're back at number 3, which is on page 296. And if you have a protractor and a compass, then get that out. If not, you'll just have to follow along with what I'm doing. Okay? All right, so basically it says Kaylee has a square piece of wood with a side length of 48 inches. She wants to use it to build the largest circular tabletop that she can. Draw the scale model of the piece of wood. Be sure to include the scale used in the model. So, of course, we can't draw something that's 48 inches because that would be huge, right? So what I did was for every 1 inch, it's going to equal it will equal 48 inches. Okay, so 1 inch is 48 inches. Equals 48 inches. Okay, so I'm going to draw my square. So that's the first thing that you guys need to do is draw a square. So there's one.
For me, your screen is frozen.
Is it? Okay. Sorry. Let me unfreeze or All right. See if that worked. Did that unfreeze it?
It did.
Okay. All right. So
what does that say next to the square?
1 inch equals 48 inches. All All right, so there's my square. All right, who remembers what I have to do with my compass? First thing I got to do is find the... Somebody just said something. Hold on. I can see it come through on my watch. All right. Until my chat's coming up, it's taking forever. All right. So what I'm going to do is I'm going to draw diagonals because that's going to help me find the center of my square. All right, so then this would be my center. Well, chat's still not coming up. All right, so then from there, I missed the answer for number 2. Can someone tell me? Number 2 to the bell ringer is $1.07. All right, so remember that if this is 1 inch, if my diameter is 1 inch, that means my radius has to be
0.5.
Yep, 0.5. All right, so number 1 for the bell ringer was either 3/7 or 43/100. All right, so that means we're going to have to take our compass and we're going to have to set it at 1/2 inch, right? Because we actually draw the circle around the radius, not the diameter. Okay?
Hey, Miss Lavelle.
Hi.
Is it okay if I did 1.5?
Oh, yeah, you could do whatever scale you wanted.
Okay, because
Yeah.
I finished this yesterday.
Yeah, that's fine. Yep. All that did was make your square bigger, and then your radius would be 0.75 instead of 0.5, right? All right, so I'm going to put it in the center. And I'm going to draw my circle. A little bit over, but it'll be all right. It doesn't have to be exact. Okay? So it says, what is the diameter of the model? Well, we already said the diameter is 1 inch. So if 1 inch here equals 48 inches, in real life, the diameter would be what? So in the model, if it's 1 inch,
48?
yeah, 48. So the tabletop in real life would be 48 inches. That's a huge tabletop. Okay? All right. So I can tell you guys, though, that on the test, you're not really going to have to draw the stuff. It's really knowing that the information. So, for example, when we drew this square, we knew that the radius was half of the diameter. And we knew that I would only be able to get a radius of 0.5 all the way around for my circle, right? So like yesterday, or not yesterday, but Friday, when we talked about triangles inside circles, remember some of them we could do multiple triangles, some of them we can only do one triangle, and some of them we could do none. So on the test, it's more relying on will it work, and if it does, how many triangles can I get within that circle, okay? So that's kind of what the lesson is looking at today. And of course, as we move on through this unit, they're going to give us some other strategies to figure all that out, okay? All right, so for the check understanding, it says draw a circle. Can you inscribe an obtuse angle? If so, inscribe an obtuse angle and tell how many can you draw. All right, so it doesn't matter how big your circle is. I think I'm going to use my centimeter side today, and I'm going to use 1.5, I think. Come on, click one more. All right, so 1.5. So I'm going to put my dot in the middle, and I'm going to draw my circle. So this one's probably going to go a little bit over the page, which is okay. And as you can see, it moved a little bit.
Is it okay to freehand this?
Yeah, it'll be all right. Like I said, it's more about understanding than it is getting it exactly. Because as you can see, my circle's not exact. But, all right. So we're going to draw a triangle, and it needs to be obtuse, right? So 99% of the time, you're not going to be able to use the diameter as one of your sides. So it's going to have to be small. So I'm going to draw a dot here, and I'm just going to draw a line from there to here. Okay, so remember, it has to be obtuse. So my 90-degree angle would be something like this right here, right? So if I drew that, that would be 90 degrees. It has to be larger than that. So I'm going to tilt it and then draw that line here so I know that it's obtuse. And then erase that 90-degree angle. And then just connect them. Okay, so there is one. So could I use the same original point and draw another one?
Wait, I thought the side had, like, it has to go through the middle.
It doesn't say that.
Oh, I thought you were supposed to.
No. So it says you can inscribe an obtuse angle. If so, inscribe an obtuse angle and tell how many you can draw. So it didn't tell me to use the diameter. So I don't have to. Okay? All right, so I'm going to use the same point. And now I can go from there to there, right? And I could probably go a little bit smaller here. Right? And then draw that line here. Okay, still obtuse. And then I probably can do another one, like from here to here. And then 90 degrees would be like that, right? So it's going to have to be a little bit wider. So what I'm trying to show you guys is that I can draw a variety of triangles within here. Because the only constraint I have is that it has to be obtuse. That's it. The side links don't matter. The angle doesn't specifically matter. Just has to be obtuse. So it says, can we draw one? So that would definitely yes, right? And then how many can we draw? We can definitely draw more than one. If you want to put infinitely many, you can write infinitely many. But we can definitely draw a lot more than one. Okay? Alright, so, hexagon. How many sides does a hexagon have?
6.
Has 6, right?
6.
So, do all hexagons have to be, the thing that looks like this? Yeah, I'm not a very good drawer of hexagons, but it doesn't always have to be that. A hexagon is any 6-sided figure. Okay? So this one, they're putting some constraints on us. So my constraint is I have to have 3 sides that are 3 units, and I have to have 2 pairs of parallel lines. So there's 1. There's 2. And then I'm going to draw like my other one. Like over here. So that is 3. So there's 3 sides. My other side, I'm going to connect with a diagonal. Doesn't really matter what the length of that side is. So if I look, if I continue this out, right, this line would be parallel to this line here. So this would be parallel to this. So that means I either need to draw something here, so it's parallel to here, or something diagonal here that is parallel to this. It doesn't matter, because I've already met my first constraint, right? 3, 3, and 3. So let's draw something that's diagonal, that's...
I have a question.
Uh-huh.
So, I know it has the rules on it, but what if, when you do it, you can have more than just 2 pairs of parallel sides?
I think it's okay. I mean, it doesn't say you can't, right? All right.
Yeah.
So I can't bring this way out here. So what has to happen is either I've got to connect another line here to be parallel with this, and then this would have to be diagonal, right? And then actually, if I did that, Lauren, what does it look like I have? These are parallel, and these are parallel. Yeah, so I have 3 pairs.
Okay. I just wanted to make sure that would work.
Yeah, I don't see why not. Yep. The other thing I could do is instead of drawing a diagonal here, I could have drawn my diagonal like here, and then I still could have made that line there, and then I would have had this and this as parallel. So a couple possibilities of what we can do, right? So this would be parallel to this, and then this would be parallel to that. Or we could do it the other way, the way I just did it. So quite a few ways we could draw that. Okay? All right, any questions so far? Nope. All right, so this one should be easy, right? So a square has a side length. So this is my square. And my side length is 2.5 meters. What would the radius of the circle be?
1.25.
Yep, because it would be half, right, of the diameter. So the diameter would be 2.5, therefore the radius would be 1.25. Yep. All right, we good on that one? All right. So I want you guys to work on 4, 5, and 6. Okay? You're skipping 7. And then I may have to help you on 9 because, matter of fact, let's go ahead and look at 9. Because some of you probably don't have compasses. Okay? All right, so 2 of them are easy, right? Because it's 90 degrees. So I just need to find the center of my circle. And then I need to draw the diameter. And your 90 degrees, guys, didn't have to be on the top. If you want to make them on the side, it doesn't really matter. So this would be Marcel. And then this one would be Tasha. All right, so then what I would do is find the 135, and then what's left over would be the 45, right? So I'm going to take my compass, my protractor, and I'm going to line it up. So we know it's obtuse. So that means I'm looking for 135. So I'm going to use the bottom numbers. So line it up. And 135 would be right there. And then remember, just make that little mark. And then come back and draw. And then this one would be Jake. And this one would be that one. Okay? All right. Everything else, I think you should be able to draw kind of free-handed. Remember, excuse me, think outside the box on number 4, guys. It says it has to be an octagon. But it does not have to look like the octagon that we're used to seeing, okay? It just has to be an 8-sided figure. All right, let me know if you have any questions or if you need help.